I would now like to try and provide an intuitive feel for the way in which the LC circuit oscillates. So what we're going to do is look at one complete cycle, one oscillation, and we're going to split that sequence into 9 different parts and graph the current. So let's do it. Looking at situation 1, we have the capacitor fully charged, maximum Q, and there's no current flow yet. This is time t is equal to 0. Electric potential energy is maximum, no magnetic energy because there's no current flow in the coil. Then the next part, number 2, the capacitor starts discharging. So the remaining charge is less, the electric field is diminished because Q is less, but now we produce a magnetic field, and if you could see the way the coil is wound, you do the right-hand corollary rule, and you would recognize that the thumb points up based on the way the current is going through the coil. So we have an intermediate amount of electric potential energy and magnetic field energy, 1/2 Li squared. So this is the magnetic field. Again, it points up, and it's of course analogous to kinetic energy because it's really the motion of charges, just like the motion of a mass. Motion of the charges in an inductor results in motional, so to speak, energy. Okay, so we have this value. If we did a careful analysis, that's the data point we have in this part of the sequence. In the third sequence, notice I have big arrows because it's like the force on the charges continues to kind of like accelerate those charges or increase their flow. So they're still being pushed, and the current is increasing even though di dt is getting less. But now, once the charge is completely vacated, goes to 0, you got maximum current flow, so you got a maximum magnetic field in this direction. It's all magnetic energy, 1/2 Li squared. There's no potential energy. So current is maximum. There it is. And then, because the coil is a current inertia, this inductor, even though the capacitor is discharged here, the current is flowing at its maximum, so it's going to continue to flow but diminish at this point because the capacitor is now discharged, but because the current continues to flow in the same direction, it's going to start charging it up in the other direction. So we have a Q, which is reversed, putting an electric field in the opposite direction. And this is happening as the magnetic field collapses. So there's U sub E, there's U sub B. They are partitioned between each other, and so we have the value we had earlier here. In terms of the current, at least, it's still the same direction of current. And this magnetic field is still collapsing, and it's still producing an EMF, which causes the current to continue till it goes to 0, but that's when you have maximum charge, big Q, in the other direction, all potential energy, no magnetic energy, the current comes to a stop. Well then, when it's fully charged, it starts discharging. So you have a buildup of current in the other direction. As the Q goes down, the electric field decreases, but it keeps pushing those charges, and we have a current now in the opposite direction. So your right-hand rule would give you a magnetic field that points downward. And so the capacitor is discharging, but we have a partition between the energies, electric and magnetic, and the current, though, has reversed direction, so you see it in the negative direction now. And then this continues to happen until the capacitor is discharged, producing a larger current, clockwise in this case, producing the largest magnetic field, so it's all magnetic field energy, no capacitor potential energy, maximum current in the negative direction. And then capacitor is discharged, but the current inertia causes the current to continue to flow, charging the capacitor up in the opposite direction again. From what it just was, same as the original direction. The B field is collapsing. It's partitioned between potential and kinetic, I want to say, which is kind of true, magnetic. And so the current is still now negative, but less. And then until the magnetic field collapses all the way, as current continues to flow and produce maximum charge on the capacitor once again, just like in the beginning. So this is the same scenario we started out with all potential energy, no magnetic energy, and we have come full circle, pun intended. And so now if we connect the dots, no, we never connect the dots, but smoothly connect the data points with a proper curve, you guessed it, we get a nice sinusoidal response. I'm hoping that that description gave you a good gut feel, a good intuitive feel for how this LC operation actually carries out its particular details throughout the sequence. Well, that oscillation analysis on the last slide took just about 6 minutes. I'm going to try and do it again in about 1 minute. So, part 1, the capacitor is fully charged. The current is 0, all energy is in the E field. In sequence 2, the capacitor starts discharging through the inductor. The current is midway between 0 and I max, and the energy is in the form of both potential and magnetic. The capacitor in sequence 3 is completely discharged now. The current is maximum, the energy is entirely in the B field in the inductor. In sequence 4, the collapsing B field of the inductor induces a current which charges the capacitor with the opposite polarity than it had in the original. But the current is still in the same direction. Now, in sequence 5, the capacitor is again fully charged, but this time with the opposite polarity. Then in sequence 6 through 9, the process reverses itself. The capacitor discharges through the inductor, creating a B field in the inductor. And then as that inductor has the B field which collapses, it recharges the capacitor as it was in the beginning. And ladies and gentlemen, there it is.